So we have the stabilising selection, which was the normal distribution, which had the bell-shaped curve with the number of individuals, the small populations. The most common allele frequency was the sort of middle-sized child, for example, and the middle-sized has more likely to survive. So this is an example of stabilising selection because the average is selected for and the extremes are selected against because they're more likely to not survive. So that's negative selection. Therefore, there's a reduction in the frequency of these alleles, and at the extremes, and there's an increase in sort of average alleles. There is also directional selection. Should we see that? Directional selection. So this is where there is a change in the environment. So the normal and most common phenotype is not longer advantageous. So this is the individuals. This is the variation, and instead of being a bell-shaped curve like before, this can change to different, because the environment has changed and there's the most common phenotype is no longer advantageous. For example, peppered moths in the Industrial Revolution, so this would have been the peppered moths. This is normal, the bell-shaped curve. They as the Industrial Revolution, they got more soot and darker. The light peppered moths were more noticeable, so they started being like natural selection, started dying, getting eaten, predated on. So that changed the bell-shaped curve to say it was more like that. Well, it would be higher than that, but that's an example of where the alleles were. It was never zero, but it was more like that. You can't really do that, so there's always some. But yeah, and then there's also disruptive selection. In the extremes are selected for and the norms selected against until that becomes the norm. So that's the opposite of stabilising selection. The rare birds are sort of fancied over by other birds as different. So you can have it as well that it goes like this. Has the opposite effect. So the more rare animals can be more attractive. So, and there was one where birds are seen as non-threatening to be average, and the different birds have been seen as more rare and more exciting. So the brighter the colour of the wings, etc., the either more threatening or more exciting the other birds seem to find them. So this changes the stabilising selection to directional selection. And this is the opposite of stabilising selection, and this is actually disruptive selection, where the extremes are selected for and the norm is selected against. So that is called disruptive selection. So that's when the norm is selected against and the extremes are selected for, opposite of stabilising selection.